Hello, my name is Mark, and today we're going to be going over solving linear equations without graphing. Remember, all this information that I have here, all this information that I am teaching, all of it is free. And all I ask for you to do is to like this video and subscribe to this channel if you have not subscribed. And make sure to check out the full playlist of all the topics that I cover to help you prepare and be confident for your upcoming IBEW math and reading comprehension test. And also, while you're at it, make sure to check out my gaming stuff because I do play games on this channel. All right, let's begin. Today, we're going to be going over solving linear equations without graphing, or as known as cutoff problems. Let's go ahead with question number 1. Consider the following formula: x equaling y minus 4. Which statement is true for this formula? Okay, in order to do this without graphing, we're going to need to find the cutoff point. And the cutoff point is when we set x to 0. So let me just go ahead and do that. Let me show you this, x equaling 0. And then I am going to substitute that into the equation. So 0 equaling y minus 4. And let me just go ahead and make that a better y. I'm going to do my y's like this. 0 equaling y minus 4, substituting x equaling 0, and we put that over there. Now I'm going to plus 4, cross that out, and then we get 4 equaling y. And then we could write this as y equaling 4, because I like my variable to the left and my number to the right. Okay, we have our cutoff point. After we find our cutoff point, now we need to test some numbers, some values above and below the cutoff point. Okay, because something happens above y equaling 4 and below y equaling 4. And just to give you guys a visual, this is y equaling 4. And then we're trying to find out, or we're trying to test each statement for y above and y below, positive or negative values. So let's go ahead and do that. Also, before I go on further, you need to know what greater than or less than equals to, right? So this sign right here, this is an inequality sign, and this means greater than. Okay? And then you have this one, and this equals less than. You must know this concept. You must know what this is for my explanations. Also, I want you to get this down too as well. When I do something like this, x greater than 0, this means, and this is an arrow, that means positive. X values greater than 0 means positive. When I say x less than 0, this equals negative. Okay? This is very important for us to determine what answer choice is true and what answer choice is false. Okay, so let's go ahead and test our values. Let's choose above, right? Let's choose above y equaling 4. Can you tell me a value that is greater than 4? So I want a value that is greater than 4. Oh, oops. Greater than 4. And let's choose an easy one. What's greater than 4? Let's choose y equaling 5. So what we're trying to find when I do this, we're trying to find this. Y greater than 4, x is either positive, right, or negative. So y greater than 4, x positive or negative. Excuse me. So I have chosen y equaling 5. And I'm going to plug the 5 into our equation here. So then I do x equaling 5 minus 4, x equaling 1. And that's a positive number. When we choose a y value that's greater than 4, we get a positive value. And that's the inequality sign that goes like this. We got a positive value. So I'm going to box this up because this is very important. Now, what I'm going to do is pick a value that is less than 4. I accidentally erased this. Okay, now I'm going to choose a value that is less than 4. And can you tell me a value that is less than 4? Very easy. Don't overcomplicate things. Y equaling 3. This value is less than 4. Remember, less than, greater than. So I'm going to plug in this 3 inside the equation. And I'm going to use a different color. X equaling 3 minus 4. And then we simplify. 3 minus 4 equals negative 1. And what is this value? That value is, it's negative. So what do we do with our statement here? I'm going to change this to orange. Y values less than 4. Then we get x negative, right? X is negative. So we have our two statements here. Our two rules, actually. I don't know what the term is for these, but I'm going to say my rules. We found our rules given the cutoff where x equaling 0 and then y equaling 4, right? Let's go ahead and test our statements. When the value of y is greater than 4, so greater than 4, right? X is negative. Well, from what we found out, x is actually positive for values greater than 4. And just to go a step further, we did y equals 5, right? Let's do y equals 6, just so you can just grasp this concept. I don't like how I wrote that 6. Okay? Now let's go ahead and plug it into the equation. X equaling 6 minus 4, x equaling 2. Remember what happened last time when we put 5 in there and then minus 4, it was 1. So we can go a step further and say as our x or as our y values increase, our x values increase too as well. But our statements don't ask that. They just ask us when the value of y is greater than 4, x is negative. Well, x is actually positive, and it becomes more positive as we choose higher y values. So we can cross this one out. When the value of y is less than 4, x is positive. So y values less than 4, we chose 3 in this case, and we got a negative x value. We got a negative 1. So this one is false because it's saying x is positive when we choose y values less than 4. That is incorrect. And then we have this one. When the value of y is greater than 4, x is positive. And that is true. C is the right answer. When the value of y is less than 4, x is 0. Well, this statement only works if it said when the value of y is 4, x is 0. Because we found where the cutoff was. And to find the cutoff is when we set x to 0. And then we solve, and then we're left with 4. In our case, we were left with 4. So this is wrong. All right. Are we tracking? So you can graph this and then test your graph against these statements. And I do have a video where I show how to solve linear equations by graphing. And I'll leave a link down in the description or a marked card above. But this video is about solving linear equations without graphing. So the main point, the main steps I want you to get from this is you need to find the cutoff. Okay? And you don't need to. That's just what I recommend. That'll give you a better picture of what's going on. With this equation, with this question, you could go ahead and just plug in numbers. And also, it's kind of a clue where the cutoff is or what the cutoff is, because in this question, right, it tells you 4, 4, 4, 4. It tells you where the cutoff is. But the thing is, it doesn't directly tell you where the cutoff is. This just is an easy question, so you can assume that this is the cutoff. But again, what I want you to do is find the cutoff. Okay? Next question. Question 2. Now this question is on the video where I did solve by graphing. And I want to show you that you could plug in numbers, plug in values, and then test the statements and still find the right answer. I did swap the answers so they are not the same. So let's go ahead and do this. We have x equals 3, y minus 4, minus 2. Which statement is true for this formula? So again, what will we do? What will we do first? So what we would do is set x equaling 0. And then when we do that, we solve and get y. So let's go ahead and do that over here. 0 equals 3, y minus 4, minus 2. 0 equals 3, y minus 12, minus 2. Then we get 0 equals 3, y minus 14, plus 14, plus 14. And then we get 14 equals 3y. Then we divide by 3, and then we get y equals 14 over 3. And this equals, how many times can 3 go into 14? It's going to be 4. And then what we're left with is 2, and then thirds. And remember to solve these improper fractions. If you want to convert it back to 14 over 3, you do 3 times 4 plus 2. Okay? And I'm just going to show you that. So 3 times 4, 12, plus 2 equals 14. And then what you're left with is y equals 14 over 3. But I like it like this. Y equals 4 2/3. And that equals our cutoff. So I'm going to put our cutoff right here. Y equals 4 2/3. Now, look at the answer choices. These answer choices are different from the previous question. This time we have 4 and then 5. So this one's different because something is happening in between 4 and 5. Okay? And just to give you guys a visual, this is y equals 4, and this is y equals 5. And something is happening in between here. And what's happening is there's a y 2/3, right? It's just above 4.5. That's what the middle is, 4.5 or 4 1/2. But 4 2/3 is just above it, right? Just above 4.5. So something is actually happening in between here, right? So if I put this in green, put a line, and I'm going to erase this right here, put a line through here, what we know at the cutoff is we're going to have negative values and we're going to have positive values. So let's go ahead and test these statements because we have to be very careful. Now let's go ahead and figure out what happens above and below the cutoff. So I'm going to start with above the cutoff, and I'm going to set y to 5. And then when I do that, y to 5, right, we are finding y values greater than 4 2/3, right? So let me go ahead and do that. X equals 3, 5 minus 4 minus 2. Then we get x equals 3. What is 5 minus 4? That's 1. Minus 2. Then we get x equaling 3 minus 2. Then we get x equaling 1. So, given this, we chose a value greater than 5, and we got a positive number, x greater than 0. That's one of our rules. Okay? Now, let's do a value less than 4 2/3. And then we're going to do this. This is our new rule that we want to figure out. Y less than 4 2/3. X is what? So let me just choose 4. So let me go plug this in. X equals 3, 4 minus 4 minus 2. X equals 3 times 0 minus 2. Then we get x equals 0 minus 2. Then we finally get x equals negative 2. So then we got a negative number. So less than 0. So here we go. And let me actually, let me just move it because I don't like it when it's on the outside. So y values less than 4 2/3, then x is less than 0 or negative. Okay, we have our rule. And this, guys, this is a trap. Okay? Oh, my gosh, loud upstairs. This is a trap. There is a trap. I'm not saying this is a trap, but there is a trap. So when the value of y is less than 4, okay, less than 4, x is positive. And that's okay. Okay, we know that nothing is happening below the value of 4, okay, because our cutoff is 4 2/3. That's okay. We can treat this as y values less than 4 2/3, x is negative. That's okay. So this statement is in fact wrong. When the value of y is greater than 4, x is positive, right? Y values greater than 4, we have 4 2/3, x is positive. Now let's go ahead and look at this right here. So it's saying y values greater than 4. Here's 4. And then we're saying greater than 4, it's positive. But there's this little section here, remember this, where it's negative because the cutoff is 4 2/3, right? So in fact, values greater than 4 are negative, but most are positive. So this is wrong. Okay? And let me prove that to you. Okay? So let me choose, before I cross it out, let me choose a value greater than 4, but then less than 5, because we tested 5. So I'm going to use 4.5. This value is greater than 4, right? So y equals 4.5. Still greater than 4, So let me plug this in. X equals 3. 4.5 minus 4 minus 2. Then I have x equaling 3. What is 4.5 minus 4? That is 0.5. Oops. My gosh, I can't just write the 0. 0.5 minus 2. 3 times 0.5, or I could rewrite it like this to make it easier for us. 3 1/2. So we have x equals 3 times 1/2 minus 2. So 3 times 1/2, you just do 3 times 1, and then you're left with x equals 3 halves minus 2. And this 3 halves, that equals 1.5 minus 2. Okay? And then you have x equals, what is 1.5 minus 2? That is 0.5. Negative 0.5. So, in fact, this is a negative number. That's a negative value. And that is what proves that this statement is false. Because I chose a value greater than 4, but it gave me a negative number, right? But if I choose 5, it gives me a positive number. Okay, so this is where you have to be careful. Remember this right here. Here's the cutoff in green. Here's 4 and here's 5. In the cutoff, you have negative values below 4 2/3. And then the cutoff above 4 2/3, you have positive numbers. Okay? So in between, there's a small in between here between 4 and 5, right? It's actually like right here, or it doesn't matter, right here. Between 4 and 5, where it's negative. So right here, now I could cross it out. Now let's go ahead and see our other answer choices. When the value of y is less than 5, x is positive. So y values less than 5, x is positive. Well, if we look at our rules over here, y values less than 5, and we chose 4, or what did we choose? We chose 3, right? We chose 3, and then we got a negative number. This rule's okay, because the cutoff is below the 5. So we could cross this out. Now that leaves us with D. When the value of y is greater than 5, x is positive. And this is our safest answer. Because look, if we go above 4 2/3, everything above it is positive. Everything for sure is positive. And then it's asking us what's happening at y equals 5, any values greater than 5, it's always going to be positive. So that makes D correct. I hope I explained that well. This one is a little confusing, and maybe, just maybe, graphing will work on this one. And I do have a video on graphing. So please let me know if you need more help on this, and I will do my best to explain it to you on our one-on-ones. Okay, next question. Question number 3. Now this one is easier because we have 4 across the map, across the whole problem. So all we have to do, now this is just extra practice, let's just set, what do we set actually? What do you set? We set x equals 0 because the first thing we want to do is to find the cutoff, and that is when x equals 0. So 0 equals 2y minus 8 plus 8 plus 8. 8 equals 2y. Divide by 2. Divide by 2. We get y equals 4. and that's our cutoff. And let's go find what happens when we choose values above our cutoff and below our cutoff. So I am going to put y equals 4 right here, and that's our cutoff. And let's just choose 5 again. Let's just choose 5. Y equals 5, and we're trying to find for y greater than 4, what are the x values, positive or negative? And let's go ahead and do that. So let's just plug in the y. So we have 2, 5, minus 8, x equals 10, minus 8, and then x equals 2. Okay, and that's a positive number. So positive values, we get positive x values whenever we have y values greater than 4. Now let's go find what happens below the cutoff, or below y equaling 4. Y equaling 4, yeah. This even confuses my head teaching it to you guys. So I'm going to choose, and I'm going to make this orange. I'm going to choose y equals 3. And our rule would be y less than 4, values less than 4, y values less than 4. What do our x values? What will our x values be? So x equals 2, 3 minus 8. X equals 6 minus 8. X equals negative 2, and we have negative x values. So let me just highlight these. Let's go ahead and test our statements. So this says y values greater than 4 yields positive x values. Y values less than 4 yields negative values, negative x values. So when the value of y is greater than 4, right here, x is negative. No, incorrect. We get positive values. When the value of y is less than 4, x is positive. And no, we get negative values. When the value of y is greater than 4, x is 0. No, because x is 0 only when y is 4, because our cutoff is 4. And remember, our cutoff can only happen when x equals 0. So this is wrong. And this renders D correct. When the value of y is less than 4, x is negative, and this is correct. D is correct. If you have any questions, leave them down in the comments below, or email me, or set a free 10-minute assessment call where we can go over one question, or we could just talk about how I could help you study for your test. So let's go ahead and go to question number 4. This is more practice. Consider the following formula. X equals 0.25y minus 4. So to solve this without graphing, what do we do? And here's a clue right here. 16, 16, 16, 16. We set x equals 0 because we need to find the cutoff. So x equaling 0, 0 equals 0.25, and I'm going to write that as 1/4 y minus 4 plus 4 plus 4, cross that out, 4 equals 1/4 y, and to get rid of this fraction, we're going to multiply by 4. Multiply both sides by 4. And then that leaves us with y equals 16. 4 times 4 is 16. Yeah, y equals 16. And that's our cutoff. So I'm going to put our cutoff over here. And let's go ahead and find out what happens above and below the cutoff. Let's go choose y values. So for this one, I'm going to choose, because I want to get rid of the fraction, I'm going to choose 20 as my value, my y value above the cutoff. Y equals 20. And then I'm trying to find values y greater than 16. And then what will my x values be? So let's go ahead and plug y as, let's go plug in 20 for y. 0. Oops. I want to change this to 1/4, right? Times y, which I made 20, minus 4. And then times the 20 by 1 and divide by 4. 20 divided by 4, that is 5. 5 minus 4. Then we get x equaling 1. And we get positive x values. So there's this is what happens when we set our y values greater than 16. So let's go ahead and I'm going to choose orange. And the number that I'm going to choose is y equaling 16. And then we are trying to find, oh no, not y is 16. Sorry. Let's choose y equaling 12. Because 12 divided by 4, that will give us a whole number. And that's what we want. And I have a gnat that is just flying around in front of my screen like you got nowhere else to fly, dude. Now got him. See, this is what I'm talking about. It's this plant I bought from Target, and it's haunting me now. Okay, so we've chose a value, a y value below our cutoff, and I've chosen y equaling 12 to make us get a whole number when we divide by 4. So let me show you what that looks like. And let me just write the inequality down, the parts that we do have. Okay, this is y less than 16. So let's just plug it in. X equals 1/4 16 minus 4. Then I get x equals 16 over 4 minus 4. And then I get x. Oh, oops. Sorry, guys. I was going to get 0 because I did the cutoff. Let's do 12. And then I get x equals 3 minus 4. And I'm running out of space. So I get x equals 3 minus 4 because 12 divided by 4 is 3. Then I carry down the -4. And then I get x equals -1. So I got a negative value, -1. So here's the rest of the rules that we just made. And I like how it boxed it up there. Why doesn't it do it all the time? Anyway, let's go test our statements. So when the value of y is less than 16, x is 0. No, in fact, when x is 0, y is 16. So it has to only be 16, then x is 0. So A is wrong. When the value of y is less than 16, x is positive. Y values less than 16, x is in fact negative. So we can cross out B. Then we have C. When the value of y is greater than 16, x is negative. No, in fact, x is positive. So that leaves us with D. When the value of y is greater than 16, x is positive. Greater than 16, x is positive. There you go. D. And that is how you answer question number 4 without graphing. Again, make sure you check out the graphing video. I believe if you figure out what's going on in the background, like how the process works, you'll better understand this right here. Okay, that's why I taught the graphing first. Because even okay, that's how I learn. I want to know like what's going on in the background. Okay, next question. Question number 5. This is the last one that has cutoff problems. These ones are relationship problems, and we won't do those. So let's go ahead and do question 5. And question 5 is a little hard because I put not true. Okay, so this one might trip you up. So we're looking for the not true one. We're so used to finding out what's true, I put not true, and this could be on the test. I also changed up the variables. They'll do that to you guys on the test. Okay, 3k equals 6m plus 18. What do we do first? In this case, we have to do some algebra. So I want to get rid of this 3. And what is the LCD, the least common denominator, for each one, for all these numbers? It's 3. Each one could be divided by 3. And then we get k equals 2m plus 6. Because 3 divided by 3 is 1. We're left with k here. 6 divided by 3 is 2. And then we carry down the m. And then 18 divided by 3 is 6. So then our equation is k equals 2m plus 6. Now we're going to set we're going to set k equaling 0 because now we need to find the cutoff. So we get 0 equals 2m plus 6 minus 6 on both sides. We get minus 6 equals 2m. Okay, divide by 2. We get negative, and I just went ahead of myself. This is actually divide by 2. Negative 3 equals m. And then I like to write it like this. And there you go. That is our cutoff. We found our cutoff. M equals negative 3. And that's just the same as y equals negative 3. Okay? Don't get tripped up. Do not get tripped up when they use different letters. M equals negative 3 is our cutoff. Now we need to find the values or what happens above our cutoff and below our cutoff. Okay? So for this one, I'm going to choose a value above our cutoff, and I'm just going to put 0. So I will use the formula. It's a k equals 2m plus 6. And I erased it down there. I should have kept it. But k equals 2m plus 6. And I will make I will make m equals 0. And these are values greater than negative 3. Okay? So I'm going to go ahead and solve. So k equals 2, 0 plus 6. K equals 0 plus 6. Then we get k equals 6. And that's a positive value. Okay? And I'm not going to box that up. That's a positive value. So when we have m values that are greater than negative 3, we get k values that are positive. Okay? That's one of our rules. Now I'm going to erase this. Oops, I erased the equation that I need to use, but good thing your boy could memorize it. So I need to choose values that are a value that is less than negative 3. And I'm going to choose negative 4. Okay, and then we get k equals 2m plus 6. And then I chose m equaling negative 4. So k equals 2 negative 4 plus 6 k equals negative 8 plus 6, k equals negative 2. So m values less than negative 3, and we get negative k values. Okay? Remember what these mean, okay? This is very important. This is very important that you know how to read this for these questions. Okay, we have everything. So let's go ahead and test the rules that we found with our statements. And we're trying to find what is not true. So 3 of these will be true. When the value of m is greater than negative 3, k is positive. And that's true. So I'm going to take that out. When the value of m is equal to negative 3, k is 0. That is also true. Now, remember, it always said like less than or greater than, and then it said k is 0. Well, now this becomes true. When the value of m is equal to negative 3, k is 0. That is true. And this could be taken out. When the value of m is less than negative 3, k is negative. M values less than negative 3, k is negative. K is negative. That's true. Remove that. Our last one, D. When the value of m is less than the negative 3, let me read that again. When the value of m is less than negative 3, k is positive. K is positive. And that is incorrect. That is not true. So D is the correct answer. It's kind of like a brain flip, okay? Excuse my language. It's called like a mind fuck, okay? When you're trying to find not true. But they will have something like this on the test. This could show up. Okay, so that's what I have for you guys. How to solve linear equations without graphing. And I know that question 2 was confusing, okay? But if you get this graph, if you just get what's going on, you'll be able to get yourself out of the trap. Please just ask me a question or questions in the comments, and I will do my best to answer them. Or if you want further explanations, just email me, okay? Everything is free. I even have the 10-minute free assessment calls where you can ask me a question. Make sure you check out all of my videos in the course. It covers many topics, and don't worry, I will be making multiple videos. And when you have a break, make sure you check out my gaming videos, okay? Because we play those too. Right now I'm playing Ninja Gaiden 4, and your boy got a copy of Fatal Frame 2. Shout out to my boy Nikki all the way in LA. I want to show this off because this game costs like more than $100. That's it. That's all I have for you guys. Marky F, baby out. I will see you in the next video.